Well, it's good to see you all. I hope you're all having a good day. Let's go ahead and get started. I'll first open up in prayer and give you a rough sense of what we'll be covering today. So, dear Heavenly Father, thank you for the chance to be working with each of the students in this course. I pray that as we progress through this material, they can get a better sense of what it means to be a systems engineer, and they can be thinking if that's the area that they'd like to pursue. If nothing else, just getting familiar with how system thinking can be quite useful in a variety of different ways. Help them as they are getting closer to navigating to getting the job that they would like as they move forward. Dear Heavenly Father, I also pray for their spiritual formation, Lord, that you would help them as they're getting a chance to be studying scripture, that those messages will be clear and impacting, and they'll get to see how the theological concepts we draw from that can be useful, and that they can be doing that now and in the future. Give them interesting and creative ways for faith integration. In Jesus' name we pray. Amen. Okay, well, we're going to continue now and getting fairly well into the integration and development phase. And so for this, and also next week we'll be off, but the following Tuesday we'll finish up with these last two chapters on system, the engineering development. And so this lecture will be talking about system integration, and then we'll finish up with test and evaluation. You can see that we're slowly working our way through the system engineering V. That's largely where it ends here at the end of this engineering development. And then we get when it's actually in its operational mode, and this whole different set of things that are discussed there. So we'll spend our time going through this as, relatively speaking, a shorter chapter, and then we'll be talking more about the state machine diagrams, and I'll walk through some more examples and leave some times that you all can share what you've got, and I'll look forward to having that dialogue. Okay, so now let's get into systems integration. So now we're wanting to think about integrating the total system. We're not just talking about modules or subsystems, we're talking about the whole system. And so the objectives of the integrated phase are to integrate the engineering components of a new system into an operating whole and demonstrate that the system meets its operational requirements. So that can be, depending on the system, it can be quite elaborate. And I keep bringing up the James Webb Space Telescope to give you an example of a very complex system. You can see that, and I'll have an illustration of that in a few slides here. The outputs of the integration phase are the validated product production designs and specifications. So you have what you're building, you have the specifications that support it. Then you have the qualifications for production and subsequent operational use. So this is how you're going to demonstrate to the sponsors, the stakeholders, that you're ready, and you have a design that's going to work, and then it's going to operate the way they would like when it's put in an operational state. The activities that are involved here are, first, the integrating the test components into subsystems, and then the subsystems into a total operating system by sequential aggregation and testing at the constituent levels. And so I've been, in the past, I've been like a subsystem engineer, I've been a systems engineer. And so you've seen things go slowly at those developmental levels, getting higher and higher, more levels of integrated things. Then we have the design and building of the integration test equipment and facilities needed to support the system integration process and demonstrate end-to-end operation. And so sometimes there are going to be some facilities that will transcend going from one specific project to another, like a thermal vac chamber. You'll see an illustration of that in a few slides. But there's also something that needs to be surgically independent for this configuration. There may be some modules you can leverage, but there's going to be hardware and software that's going to be specifically for this system. Now we're getting into what we're doing for the integration and evaluation phase here. So that's in the middle. We had the engineering design that came before it. Now we're thinking about the system integration, system test, operational evaluation, all of the things. That this is the sweet spot for where we're going here. So we have the test and evaluation plans, those flow into this. the engineered components, the hardware flows into this. And the outcome of this is we're going to have all of the specifications and the documentations that are needed. And then we actually have the production system that has actually been validated. And then we can go into deployment, or if there's multiple articles of the same thing, say you can think like the GPS constellation, it has at least 24 satellites to make it fully operational. So there's a couple of different types of systems integration approaches. I'll have a chart for the first two, and then I'll just briefly talk to this third one here. So the three main approaches are taken when integrating systems, which will require a system architecture and overall plan to follow during the system development. The first one is the top-down integration. So this starts with an overall system concept and decomposes down to the subsystems and component levels. Maybe there are some examples where this can be done. The one that I've seen mostly is this bottom-up integration, where you're starting with the components and forming into larger groups such as subsystems and ultimately the system. And finally, you have what's called Big Bang integration, where all the elements are provided and then integrated. Typically, this works best for small scale and less complex interfaces. So those are the three types. And we'll get to these charts that will go into a little bit more detail in a second. So for the system integration planning and facilities, the facilities to perform the integration may occur in the same location, or it could be a different location. The James Webb Space Telescope actually got a lot of frequent flyer miles going around the country with the various places that things are made in different areas, and then it's finally has its overall integration in Houston. So it's depending on the size and the complexity of the project. And so with a large thermal vac chamber that they could use is in Houston at the Johnson Space Center. So the system is a large scale effort that involves different companies and countries. There may be cultural, organizational, or language barriers that must be overcome to ensure that the integration objectives are understood and achieved. And so for the James Webb Space Telescope, there was the United States, there was Canada, there was a European community. So there was a lot of different foreign international players that were part of that consortium. So now we can be seeing what happens at the subsystem configuration. So you can think from this this bottoms up level. Now we're thinking at the subsystem level, and you can have the subsystem that's being tested, and maybe there's multiple components that are composed of that. And so that can be feeding out into an output analyzer. You also can have a subsystems model. And so you can be comparing those and seeing which one is this subsystem actually performing adequately as compared to the predicted responses, or what the model actually produces as realistic examples of what the actual hardware would do. You have the test manager that is actually in control of this, that's performing the test and the criteria. And you have the test control unit that is the one that is controlling the inputs. And so thus you're trying to focus on validating that the subsystem is working properly. So here is this top-down integration approach, and you start at the top and you work your way down. So that is something that can be a possibility. I personally have not been in this type of an integration, but this is something that completes a complement of what things are like. I'm kind of speculating that maybe with an automotive assembly line, maybe there might be something where you can have a sort of an aggregation of a top down and a bottoms up. So this is the one I'm mostly familiar with. You start with the lowest level, the configuration items that fit into a component. So this is going to have here 3 different things that are related to this component. These components are aggregated to form the subsystem, and then these subsystems are aggregated into the system. So you have unit test, you have subsystem test, and then you finally have system test. That's really what I've seen over and over again. So Big Bang integration, that it's little bit of both of these, top down, bottoms up. And so say after you've demonstrated the first article, and maybe some of these things can be streamlined, and so maybe you just stick everything together and then you test it, because the risk has been minimized due to earlier blocks that have been already done, or saying if you're working on the 24th of 24 satellites for GPS constellation, maybe that's where that might actually come into play. There's a lot of integration planning that has to take place. You can be thinking about all of these levels of testing. And so sometimes that one of these subsystems will be made by a different vendor. And so they are going to have their own testing that is then going to fit in a little bit more formally than it would be if they were all integrated by the same company, because there's contractual relationships that have to be honored going from one to the other. Then there's the integration facilities. I'll show you in just a minute a complicated integration facility for hardware. There's also the software integration facilities as you're trying to make all of the software things work out together. And then there's the human factors integration. So you have the hardware and software, the cyber physical realization that you're trying to make sure that this all is making sense. And so those are all things that come into play for the integration facilities. So you're designing the hardware and software. You're also having to design the integration and testing facilities to make that all work. So here is just an image of what the flight chamber that was used for the assembled James Webb Space Telescope. This may actually just be the optical without all of the bus hardware and stuff like that. But anyway, this is just representative of the flight chamber. And so when they close the door, I know this is right here, but there's actually a door that fits into this. And then they pump it down to a vacuum, and then they do thermal cycle. So it's this something called a thermal vacuum chamber. And just to give you an idea of the size, you can see people here versus all of the hardware, all of the support testing interfaces that have to go into the chamber. And then there would be a lot of different cables that would be going outside the chamber with the test equipment that would be integrating with that. So this is at the Johnson Space Center in Houston, Texas, where this chamber is located. The Goddard Flight Center was back in Maryland, was the major integrator. And so there was a lot of development back there, but eventually they'd have to have it go out to Houston to have things integrated. JPL was also part of that, as well as the European Space Agency and the Canadian Space Agency, which I also mentioned. So this is, relatively speaking, a short chapter. We got a chance to be talking about the integrating the total system, the different approaches that are there, the top down, the bottoms up, and the Big Bang approaches. We can be thinking about the system integration, how that's going to come about. And then we also talked about the system integration planning and facilities. So something like this is going to be a facility that you want to be using again and again, because this is quite expensive, but there's also going to be things that are dedicated for the specific capabilities. So the one that I have been using as a thought piece to use as a point example is the James Webb Space Telescope. So let me see if there's any comments or questions on what we covered there. Maybe just give a thumbs up if you're following along with what we got there. Okay, sounds good. Well, let me transition over to examples of doing some of these models. And I've already showed you this one our last meeting, but I'll just go over this a little bit more and try and give you an idea of the states and what the transitions might look like. And so here we have a power on state. And so here, whenever the power is turned on, we would have it flow into this mode. And so we have then at this point, what I was envisioning that, well, this means that the power would be distributed to the various units. And so they could start to get ready for going into the next step. And the one that I'm highlighting here is going into a self-check mode. So you can see that there's the entry and exit conditions and what it does during while it's actually in that mode. And here it would be distribute power. And I use the analogy in our last meeting of the computer. When you first turn on your computer, what it does is it starts this sequence, distributes power, engages at a low level. Even before it engages the operating system, it does a built-in test equipment, a byte with a BIOS. It actually does a sanity check to see if everything is fine. If there was an error in the hardware or something, it's actually going to show up on your screen, and it's actually not going to boot up to the next level. So here I given it this example, and so it does this initial checkout, and then I have this this idea of a true or false, and so either if it passed, then I could say it would be a yes, or if it doesn't, then it would get into this mode where it would respond in terms of a no. So and this is just I could think of like the term in software I would think is like a code stub, and so I'm just going to have it go to this final turnoff state. Something's not wrong. What you would want is to have a minimal type of capability so that you still can have some rudimentary commanding to maybe try and cycle through some of the redundant hardware if you had something like a satellite. So this is just a kind of a rough sense of what some of that would look like. Then I get into some of the actual operational things. And so what I call process telemetry and commands. And so it gets into the state after it's passed the initial BIOS checkout, the byte. And then here it's able to process commands or telemetry. And so the main one that I focus on here is that a command gets sent that you want to actually do something with your sensors. You notice the fact is I'm not getting into the details of what the sensor is doing. It's just the fact that it's in the sensor collect mode. And then it does that sensor request. And when it's done, it just then returns that to where it's able to receive another command, and it's also going to be sending the results of that testing um, um, since it's completed. I also put in another thing here, which is a choice. And so is the mission complete? If it is, then it transitions to the mission complete state. And what it does then, it does do a final turnoff. And guess what? If you're thousands of miles away and you turn off the power, it's never going to turn back on. So this is definitely a terminal state that we're seeing in that situation. So I would envision that you all would try and make maybe one or two of these kind of state machines. And let me click over to the Cameo Systems Modeler and show you some simple examples, and then I'll get a chance to show you something that's a little bit more complicated. And so here we can see the transmitter. And so say you can think for a communication that's either transmitting or non-transmitting. And so we can have these kind of states. I can actually run this and we could see this transition. There's one that's going to be a little bit more complicated that I'll show you that. And so with this tool, and unfortunately with the level of tool that you have with visual paradigms, you're not able to do this actual executability. You can do this with the activity diagrams. We've seen it with the sequence diagrams, and now we're going to be seeing it with the state machine diagrams. So here's one example. I'm going to come back to this one. This is the kind of the most complicated one here. So I'm just going to rearrange these a little bit, go from simple to more complicated if I can get these things. So I showed you that one. So here is just a simple, we transition from on to off. And so we have the initial state and it's off. It gets a power on command and then it goes to the on. And here it does the sensing of the thermal emissions. So an infrared sensor is on. And then it can actually, if it receives the off command, it goes back here. And so we're going to be going back between these two states. We don't see a final terminal node being here, but we do see a start mode that's here. And so here we have a value that's included with this. That the power is equal to 0. Here we've included another variable here that the power is less than 60. So 60 something, 60 watts, 60 milliwatts, something like that, but we're seeing the same general kind of characteristic going from one state to another. Here we can see the solar panels. And so here we can see that we go from either the solar panels are not there. So we're in the shade, maybe you're in an eclipse. So they're not exposed, and here they are exposed. And here we can be seen, we're putting an equation here for the amount of power. So the power density times the area times the cosine of the sun angle, that's what's going to be defining how much power is going to be generated. So that's something that you could include with this. But for right now, I'm just going to just to leave that as a for your information. Okay, this will be the first of 2 ones that I'll try and do the execution just so you can get a little chance to see what that looks like. And so here we can see that it can goes into an operation. So it's either in normal mode or safe mode. And so the safe mode would be like what I'm saying here. Say it doesn't pass a self-test. I didn't actually put this in here, but this would be an example. It's going into a safe minimal capability that what you are trying to do is get it back into a normal mode. And so you're going to be doing some diagnostics if you're into that type of a mode. And so here you could be seeing an example of what you would be doing in terms of some of those diagnostics. And so maybe you find out that a unit failed, and so you're going to have to switch to a redundant unit and then hopefully get it back to the normal state. Now, I didn't program this, and so this is going to be something that I didn't have time to preview this before. So what I'm going to do is now just run this. And so I'll show you some of the things that are here. Okay, so we can see that we're in the normal operating mode. The error response is in a wait because there isn't anything that is detected as being anomalous. Since I got this field down the bottom, I'm sorry, I'm making this smaller so we can see the whole thing. And so now I have this kind of a menu where I can change what type of state that I'm at. And so here, let me do the resume normal operation. Okay, so we're in normal operation. Okay, we were before, so nothing changed. Let's do an error detected. So here we see it goes into the local response. And so this is, for us, in a sense, is like a code stub. And so I have the choice of either saying that was the error resolved? And so for right now, I'll say yes. So we send a system response. And then I can say, was the system response complete? I can say yes. it goes back into the system response complete. And so we're in the operational mode. And so thus we can be starting to check out the logic. Does this seems to make sense with what we're doing? Or maybe if this is a block upgrade, we can go back and think, well, what did we do when we were doing some error detections on Hubble? They've had some challenges at times, or they've had to switch hardware into redundant set. And so those are some things that are possible for that has taken place. Okay, well, let's click on this other one, this mission critical threshold, see what happens here. So this puts us into that safe mode. And so this is, and so now it's in the safe mode. Let's see what happens if we put the error detection. If I click no, it's just going to stay in that mode here. But if I, through some external intervention, I was able to say, yep, we're able to figure out what it is. And so now I can put it back into, trigger it to go back into normal operation. And so here it goes back, it leaves the safe mode and goes back into the normal mode. So hopefully you're tracking what I'm showing here. Are you starting to get a better sense for how this executability can be a useful feature to get a little bit deeper with what you can be doing with model-based system engineering? Are you guys tracking that? Just give me a thumbs up if you're tracking that. Okay. Let's go to this last one, and this is the most complicated one. And so let me just try doing this first. Let me get rid of this here, and let me just blow this up to make sure that you're seeing all of this. So this is showing the spacecraft states. And so we have the initial power up. So it's off. When we get into the powering up, we can have the powering down. And then in the on, then we have all of these substates that are here. We have this normal safe mode that we saw in that last one. Here we get into the initial launch. We get into the separation. We get it into the proper orbit, and then we get into yet another substates at a level below this this initial deployment. And then we have either the sensing or non-sensing. And then we have something else for this link is available or not available. And so here we have that decision that I showed you in the one that I was sharing with you previously. Okay, well, let me start the execution. And so I'm going to resize this so it fits all the way up there. And so here we can see that there's a lot more choices that we have here. And so I'm just going to start it. Okay, so it's in the off state. So, but it's ready to start to be doing things. And so I'm going to click on the power on. So now it's powered on. And so since it's powered on, it's now in this on state. And so it initializes these other states. So it's in normal operating mode, but it hasn't been launched. And so this could be the way it was on the launch pad, is that it's a very low level of functionality, but it has to wait for some other things to take place. And so let's do a launch. Okay, so it's launched. That's it's now in that mode, but the next thing it has to do the separation. And so these are in alphabetical order. So we do the spacecraft separation. So it moves us over there. Now we're into that state. We have the spacecraft separation complete, and that's going to move us down here. Okay. And then finally, we have to transition to the proper orbit. So here we do that. Now I'm into this on orbit. Now we're in normal mode, and it has two things that are available here. We can either go from sensing or non-sensing, and we have this as set up that we could just have with this kind of a delay. It's just trying to give us a sense of what it would be like when not the link is available. So if we're in low Earth orbit, there's only a certain amount of time that we're going to be in line of sight for the ground station. So we can see how this would be a way of giving us a sense of what that logic would be. And then we have, well, are we in the field of view for what we would want to sense? All of that would be possible. Okay, well, let me let's say that we're concerned about something. There was a spike in the telemetry, and so we wanted to put it into autonomous safe mode. So it's going to be moving here. So let's see what happens when we do that. So we transition this into safe mode. It's not sensing. This link is still looking for the ability to be sending or receiving information. Let's say, okay, well, we were able to overcome that and things are going fine again. So this might be the right command. Okay, yeah, got it back into normal mode. Okay. One other command, I'm not sure what this will do, the ground command safe. This may just stick it over here as well. Yeah, so that also would get us into that safe mode. So there's a couple possibilities in which that would work. So some of this exercise, you might say that, well, we need to have some more commands. There's a state that we didn't have that needs to be included. There's nothing here for switching to redundant hardware. That could be an example, since that was something that I mentioned. And let's just say that we're going to be finishing up the mission, and so we'll start to do this deorbit command. So the first thing I'll do is do that. So we're into the deorbit, and then finally we have the deorbit complete. And that'll put us into the final state. And if I do power off, let me see if that powers off. Okay, so that's just a quick tour of a couple of different state machines. I'm going to go ahead and stop sharing my screen and in a minute. But first of all, thumbs up if you guys were able to track what I'm doing here, just trying to give you a couple examples. Does that make sense? Okay, well, let's just have a conversation. I've also set it up that you can share your screen if you'd like to get a chance to talk through your state machine diagram and maybe some other diagrams, just to give you the picture of what you've actually accomplished so far with your model-based system engineering work on your projects. Anybody feel like sharing? Well, maybe I'll just go around the virtual room. Um, let's see, Nathaniel, you want to get a chance to share what you have?
Sure, yeah. So I just started on mine, so I don't really have too much, but I was thinking of doing like the launch itself.
Hmm.
Well, like first going into the launch and then what it's gonna do when it's up there. So
Yeah.
the first thing that comes to mind is like before I launch my missile, I want the platform. Well, I need the door to open and I want to raise the platform that way
Hmm.
and get like the fuel in there because I think I don't want to keep the fuel in the missile. I want to keep it pretty much below it and then just raise it up into position for launch so that it's only in there when it needs to be.
Okay.
Um, and the missile, like, so when it gets the command, it's going to keep checking for everything. Like, just clarify that it really is supposed to launch
Hmm.
before it does, right? And then um, double check that the infrastructure is all set the way it should be, and then we're going to launch. So then in my missiles um, flight, I picture kind of like three phases. So the first phase is more to just get the missile up. It's the like heavier phase on the launch.
Yeah.
And I'm gonna want to detach all that booster stuff after it's done and it's did its part. So then the second phase is more trying to get it like pretty much in the area that it's supposed to be. So once it's up pretty high, then go, it's gonna continue its path. So it's more a kick in the right direction. And then the third phase is that final kick to deliver the
Hmm.
blow. So, but each phase, I think I'm gonna detach, except maybe the third phase. It doesn't really matter if I detach, but so there's that, and then I'm not sure like how I wanna um what's it called? I'm not sure like because I need the navigation stuff to be checking constantly in this stuff, right?
Yeah.
So I'm not sure how best to put that in here. Like I just started, so it's pretty bare right now.
Well, thank you for sharing that, Nathaniel. Just to give you a sense, just to reflect back, that was actually a fairly detailed conversation of operation that you're trying to put together. And so that's exactly what system engineers do. Is you're trying to figure out how you're going to have this operation unfold. And so here is a diagram that can be helping you do that. And you've already scoped out some of the things that you want to have it do. And then it's just a matter of piecing it together and then having a chance to review the logic to see if you think that's adequate, or maybe you might need to add some more capability, or having maybe a high level state machine diagram, and then you have one that has states within states. That's I was showing you a couple examples of that. So I think that looks good. So thank you, Nathaniel, for sharing that.
Yep. I also have one more question. How do you like put the words beneath the state? Because like
Um,
I don't know how you did it on your diagram.
okay, well, those are actually with the lines that are connecting them. You were
Oh,
able to annotate those lines, and that's where those words came from.
got it.
I can show you that in a minute after I just finish going around the virtual room. But if you want to try, if you know of any two blocks that you want to connect, I can try and show you how to do that.
Oh
Um,
no, that makes sense. That makes sense. Thank you.
okay. So, Jonathan, you want to share how things are going for you?
Sure. Mine's pretty simple right now, but I can share it.
That's fine. Simple is a good place to start. So,
So this is what I have so far. I wanted to highlight the operations of how you would initially turn on the reactor from like the
mhm.
shutdown into the on phase. And then moving forward, I want to add more detail on how the phase of it operating on a regular basis would work as well. So this is what I have so far.
Yeah, before you just leave that line of thought, this would be a great state machine diagram. And then you could create another one and put in that detail, that extra detail. I showed you some examples, like in our last meeting where Friedenthal did that, where he was talking about like a surveillance system. You just have the top level or a car, and you can start to be capturing that in more depth. And so that would be great. And like I said, this is one of several modes that it needs to operate in. You can have like a mode where it's having an anomalous situation that it's trying to troubleshoot. Yeah, so I think that the sky's the limit, but I think this looks pretty good. And you can see Nathaniel how he has the labels on here. So that's literally like he has the diamond there. That's the name of that diamond. And so he's named the nodes, the start and the stop, all of that is there. So all this looks good. Any comments or questions from you, Jonathan, or anybody else?
How does how do you get like the line like the line in the state and then like the words under that?
Okay, well, let's see if Jonathan, you want to show how you got the entry, the exit, and the due states, how you populated that?
Yeah, sure. So I just clicked this little thing right here, and then you can put them in.
Yeah, and that's actually a pretty cool feature. And another thing you can do, Abby, you can also just right click and click on specification, and that's what he has. He's clicked at the specification, and then what you can do, you can create a new, if you just like click on that down arrow next to the water pump activation on the right, you can see that you can create an activity. I'm not saying that's what he's going to do because he's got what he wants there, but that just gives you an idea. And that's how you start to create that logic. That's a good question, Abby. Does that help?
Yeah, thank you.
Okay. Well, thank you very much for sharing that, Jonathan.
Yeah.
Well, let's turn it over to Abby. Do you want to get a chance to share what you have? Is your laptop up and running now?
Yeah. Can you see?
Yeah. Mm-hmm.
Okay, yeah, this is what I have so far. So I split it into like the states off and on, and then like if it's using the battery or the gasoline engine, and
Yeah.
then also manual and auto drive. And I'm not sure if I should break up auto drive into like more states with the cameras and sensors.
Well, you
But
could actually put another set of states within that state. And so just like I was telling Jonathan, maybe this is detailed enough, and then you make a copy of this, and then you put in more details for auto drive, or you just have another one that's just focusing on the auto drive component by itself. So you can think through what you would like to do. You can see how you get those nested things, especially with complicated systems. This is the kind of thing that's going to be there. So why don't you just click on that electric battery again, or whatever one you want. And so if you just right click on that.
is it this with the?
Yeah, I think,
Oh,
yeah, either way, that's how you get a chance to be, I think, yeah, you went into a different mode. I'm not sure. I think you have yeah, that one. So if you just,
oh, like this.
there you go. You got it.
Okay. And I need that for each state?
Yeah, you want,
Alright.
that you don't have to, but that gives you more fidelity of what that state is all about, how you get into that state, how you leave it, and what does it do while it's in that state. Those are the three things that you're you're able to do within the SysML specification with this type of a diagram.
Okay.
Yeah, but I think this is coming together nicely, Abby.
Okay. Thank you.
Kyle, I'll turn it over to you. Why don't you tell us how things are going with your project? Abby, you can stop sharing your screen whenever you're ready. So, and if nothing else, you can just have a little conversation, or if you want to share your screen, maybe we can help you in any way that you feel like you need some help there. Okay?
Okay. I don't have too much to share, but let's see, there's the share screen button. So one thing that I realized that I haven't been taking into account like earlier is that why does it look like it? Okay. Is that the CubeSat has to actually send data back to the ground station. So I really
Mhm.
should have like a state in there for it. So like the current states I'm thinking are we have an active state where it's like taking in data, and
Yeah.
then when it's behind it's on the dark side of the earth, then it's going to a processing stage where it's going to actually process the data, and then whenever it's like over our ground station, then it's going to go into sending phase. And I'm not sure if I still need a charging phase though, because the like the currently at sea, like originally the idea was that we can't let it run out of power, because then once it gets power again, there's nothing to like reboot it.
Yeah.
But it from what I'm seeing about like all the hardware we're using, it doesn't seem like that's actually an issue. It'll just restart when it gets power. But I'm wondering if I should have a charging phase, just so that on the dark side it has like the ability to do the sending and processing phases.
Well, actually, that's a good system engineering question, and it gets into what you envision you're going to be doing with your CubeSat. So some of you, maybe you've taken computer architectures, or maybe the IoT class where you've got a chance to play with an Arduino. And so once you've loaded that into its ROM, and so anytime you apply power, it's just going to start doing that program that you've made it to do. And so I think that's what you're alluding to. And so, Kyle, but so at a very basic level, that may be adequate. But then you may also want to be thinking a charging mode may be that you know that there's an eclipse coming up, that you need to be doing a collect during an eclipse. And so you're going to need your batteries charged up to at least 50 to 75%. And so a charging mode could be something that's more indicative of a more complicated type of scenario you're trying to capture in your states. You see what I'm saying?
Yeah, I think I do.
So yeah, just I think you're on the right mode of starting to capture these different functionalities, and hopefully you're getting a chance to see what each one of these document types, each one of them does a slightly different thing, but there is some overlap, and it's putting them together. You can be getting a nice story of what you're going to be accomplishing with your system. Okay.
Okay. Thank
Any
you.
questions, Kyle?
Not really.
Okay. Sounds good. Well, thank you for giving us an update. Okay, I think that's probably a good breaking point. We're seeing a little bit of a trajectory that's starting to go forward, that according to our basic lectures, we've made it through the basic design. Now we're finishing up. I'll just briefly share my screen just to give an addendum for where we're going from here. So we just talked about the system integration. Now we're going to be getting into the test and evaluation. So that's going to be the end of the second major phase. Now we get into operational support, also production. And so we have a factory that's fully up and running. It's like for when they do a Tesla manufacturing, it can actually take them a year or so to get to a place where they have production up and running. There's a lot of things that need to be tweaked. It's different, but another thing that I'm familiar with, chip manufacturing, it can take them a couple of years and billions of dollars to get a production line going, and then they literally run it 24 hours a day, 7 days a week, and just crank out all of the chips that they need. And maybe they run that for a year, and so that's how they can get the unit cost way down. And so we have production. We'll be talking about how things are, what we do in an operational sense. And so it's deployed. And now you can think like Kyle with his satellite in orbit. How do we continue to maintain it being viable for as long as we can? But the James Webb Space Telescope is designed for about a 10-year life. How do we make sure that it at least lasts that long? And so those are some things that we'll be coming to next. All right, well, I hope everybody enjoys their spring break. And we will see each other a week from Tuesday. And if you do need anything comes up, please feel free to contact me and I'll be glad to help you out. Okay? God bless you all. Take care.
Thank you.
Thank you.
Great, Professor.